Welcome back. In this video, we are going to discuss about few of the heap functions which you will use in your program when you will create a new heap and you will manage the new blocks of memory that you will allocate on this new heap. So let's see what are those important heap functions that you can use. The very first function is the heap create function. It is used to create a new heap, and after the successful creation of the heap area, it returns a handle. We will discuss about the handles in the coming videos when we will discuss about the kernel objects in Windows. Then, the next function is heap alloc. As the name suggests, this function allocates the memory block and returns the address of the newly allocated block. Then we have Heap Realloc function. Heap Realloc function resizes the memory block and returns the new block or old block address based on the memory block moved or not. We will discuss this later in detail. Then we have heap size function. This is relatively simple functions and no need of any further explanation. It simply returns the size of the heap that you have allocated. Then we have heap free function. With the heap free function, we can free the entire memory on the single heap rather than removing the memory area one by one, just like we do in case of linked list or binary search trees and when you are using the system default heap. Then we have heap destroy function. With the help of this function, we destroy the heap. There is a difference between the heap free and heap destroy. After the heap free function, the heap is still available for allocating the new memory blocks. But after heap destroy, there is no scope of allocating a new memory block because the entire heap itself will be destroyed. There are three functions, heap create, heap alloc, and heap realloc, that we discussed. These need the discussion in detail. The rest of the three functions, heap size, heap free, and heap destroy, these are relatively simple. So we are not going to discuss them in detail. Let's see the very first function, heap create. This is the signature of heap create function. There are three arguments. Let's see. The very first option is FDW options. There are three values. These values can be added using the bitwise operator. If you want to provide heap generate exception and the heap no serialize, then you can use the bitwise operator to provide both the values. Then the second argument is the initial size, and the third argument is the maximum size of the heap that you have to allocate. Let's discuss in detail about the heap generate exception and heap no serialize options. In case you provide the heap generate exception option as the FDW options, then in that case, if this heap create function is not able to create a heap, in that case, it will generate the exception. It will throw an exception. Let's see about the heap no serialize. In case you use this function, heap no serialize, in that case, your heap will not be serialized, which means that whatever heap you have created, the access from different threads will not be synchronized or serialized. So, you should use this very cautiously. You should use this only when you are sure that there will be no two or more than two threads which will be accessing your heap area at the same time. That we have discussed right now. This line you can see, heap no serialize is not encouraged until you are sure about your low-level design. The next line is just a fact that you must need to remember, that heaps are by default serialized. Any heap that you create using the heap create or the system default heap is always synchronized or serialized. Then the next item or the next line is again a fact which says that heap blocks are managed as the linked list of blocks. What does this mean? This means that whenever you allocate the memory on the heap, in that case, the entire available memory is available in the form of blocks, and these blocks are maintained as the linked list. That is the meaning of this line. Let's go to the heap alloc function. In case of heap alloc function, you can see these are the arguments, and this is the signature of the heap alloc function. There are three arguments. The very first argument is heap handle. This handle you find from the heap create function. The second argument is the set of flags, which can again be provided as a set of values divided by the bitwise operators. Or you can say that you can provide the two or all the options with the bitwise operator. The heap 0 memory means that after allocating the block, entire block should be initialized with 0. Then the next argument, or you can say the next option that you can use as the flag, is heap generate exception. With the heap generate exception, you are indicating that if the memory block is not allocated, in that case it will generate the exception. Then we have heap no serialize. This heap no serialize means that for this particular call only, not for the entire heap, but only for this particular call, your heap access will not be serialized. But again, this one is highly discouraged option to be used with heap alloc function, because there may be other threads which are accessing that particular heap, and they are accessing the heap in a synchronized, or you can say in serialized manner. Then the last option is DW bytes, which is very much evident that it indicates the number of bytes to be allocated. Now, this is a point that I have written, we have already discussed. Heap no serialize is used to serialize this particular call, not to serialize this particular call. And it should be used with caution and is highly discouraged. Please mind it that you should read this line as heap no serialize is used to not serialize this particular call. Here you need to read like used to not serialize. Then the next point to understand is that how it allocates the memory on the heap. As we know that the entire memory is maintained as a linked list in the heap. So when you call the heap alloc function, it tries to find out one free block of memory in the heap. And once it finds that free block, in that case, it marks that particular node of the linked list as allocated and returns the address of this block. Let's discuss about the heap realloc function. And please Don't mind this already visible option here. We will discuss in flow, but somehow I left it while I was creating the PPT. So please, so here is the signature of heap realloc function. It takes 4 arguments, but there is only one argument that we should discuss, and that argument is fdw flag. There are various options that you can provide as the flag here. One is heap generate exceptions. This you already understand that what does this mean. Then heap no serialize that we have already discussed, and this is same as it was for heap alloc. Then heap zero memory, it is again same as the heap alloc function. And we have heap realloc in place only. We will discuss that in detail very soon. So let's see the different cases for reallocating the memory. The very first case is when the memory to allocate is bigger than the existing. What does this mean? Suppose you allocated a memory block of 32 bytes and this had the address 0x400. Now you want to reallocate this memory area and you want the new size as the 40 bytes. In case you need the 40 bytes, there are two cases. And the first case is that you get the additional 8 bytes. 32 bytes are there and you need additional 8 bytes. And you get these additional 8 bytes adjacent to these 32 bytes. In that case, you don't need to change this address. You can leave this entire memory allocated at this 0x400 because you got the 8 extra bytes adjacent to this memory area. So in this case, you will be able to get the same memory address. But in case you have not got this 8 bytes, system didn't get this 8 bytes adjacent to these 32 bytes. In this case, it will free these 32 bytes and it will find a suitable block of 40 bytes and it will allocate a new memory area and it will return a new address for this block after heap realloc. So these are the two cases and you don't know what case will execute. So you need to always capture the new memory address and you should not assume that it will return the existing address. It can return the new address as well. So every time after the heap realloc, you should capture the new memory address. Then we have this case 2. The case 2 is very simple. The case 2 says that the memory after the reallocation you want is smaller than the existing one. In that case, you can very easily understand that existing address will be returned, because if you are going to make it from 32 to 28 bytes, for example, in that case you need to minus 4 bytes, which can easily be done at the same address, being at the same address. So in case memory to be allocated is smaller than existing, in that case you will get the same memory address after heap realloc call. You can check this by writing your own program. Then we have this heap realloc in place only. It means that you can only allocate the memory using heap realloc only if the extra bytes are available adjacent to these 32 bytes or existing bytes that you have allocated. But in case you have to move the location, in that case, with this option, your function will fail and it will return null. So I hope you got the point and you have understood all of these heap related functions. In the next video, we will see some code example. Thank you.